We are looking today at trigonometric equations. Okay, so one of the things that we really need to be aware of is basically how to solve trigonometric equations, but also the impact of the restricted domain. And then we'll have a look at a contextual question at the end. So trigonometric equations. Consider the following. So are these two equations equivalent? Discuss with the person next to you. Okay, so if we look at the equation 2, in equation 2, this implies that x is equal to pi over 6. This implies x is equal to pi over 6. What about equation 1? Jude says there's two answers. Jude says pi over 6 or 5 pi over 6. Is she right? Are there any more? Jude? Plus n2 pi on both. Are there any more? No, that would be minus a half. This is the full set of solutions. How many solutions is this? This is an infinite. This is infinite set of solutions. Now, why is the second equation, equation 2, only got one solution? What has a domain of negative pi over 2 to pi over 2? Yeah. What's that called? Yeah. So f of x is equal to arc sine of x has a restricted domain of minus pi over 2 to pi over 2. Whereas the equation that we're looking at there requires that we solve the intersection between this horizontal line, which is the line y is equal to a half, and the terminal side, where the terminal side meets it in these two places at two possible angles. This angle here is pi over 6. This angle here is 5 pi over 6. And then we can take the terminal side and we can rotate it around a 2 pi multiple times in either direction to get our other solutions. Okay, so we're looking there at the general format for solving equations and finding the multiple solutions. So we have a general form. This isn't quite a general form, is it? So if I'll just generalize it a little, the first one a little more. If sine x is equal to a, then x is equal to arc sine of a plus n2 pi. N2 pi. Or x is equal to pi minus arc sine of a plus n2 pi. So this is like a general solution. Let me just do them all. For the cosine one, I'll squeeze it in down here. If the cosine of x is equal to a, then x is equal to plus and minus arc sine of a plus n2 pi. And for tangent, if x is equal to tan a, if tan x is equal to a, then x is equal to arc tan of a plus n pi. Why is this n2 pi, this n2 pi, but this one only n pi? Oh, yeah, sorry, I see it. This is arc cos. Why is it n2 pi and the other one only n pi? Exactly. All right, let's move on. Have a go at solving these three equations. 5 minutes. All right, so let's solve each one. What's the principal angle for arc cosine of minus root 2 over 2? This one should be 3 pi over 4, that's right. So this is going to give us x. X is equal to 3 pi over 4 plus and minus plus n2 pi. Why is it plus and minus? Let's have a little look on the unit circle. So here on the unit circle, what we want is the cosine of x, that's the x coordinate in this case for the unit circle, to be minus 0.7. So x is equal to minus root 2 over 2. We have two possible angles that fit this. We've got this one here at 3 pi over 4. And we have this one here at minus 3 pi over 4. Because of the n2 pi, we only need these two, and then we can rotate it around. So from 0 to 2 pi, what would be the second solution? In the interval 0 to 2 pi, what would be the second solution? 5 pi over 4. Yeah. So this one could also be 5 pi over 4. It's just quicker and easier to write plus minus like that one. All right then. So let's try this one up again for the second one. So for number 2, we've got our unit circle looking like this. And this time we need the y value to be minus 1. So we've got, I'll draw it here. We've got this here. This is the line y is equal to minus 1. So what is the solution to this one? X is equal to 3 pi over 2. Which angle would arc sine of minus 1 give us? Which angle would arc sine? So if we were to write x equals arc sine of minus 1 plus n2 pi, that's all the solutions. So what would that give us? Okay, let me hear the answers and I'll show you where they are. Yusuf, what did you say? 3 pi over 2. That's not in the domain of arc sine of minus 1. I mean, not in the range. So the arc sine is going to give us minus pi over 2 plus n2 pi. Our other angle would be pi minus this, but that's still going to land us in the same place. We can see there's only one set of solutions at this location, but like what we can do is we can rewrite this if we want. We prefer 3 pi over 2 plus n2 pi as our solutions. We're basically just adding one lot of 2 pi to the previous one, bring it into the interval from 0 to 2 pi. Both of those two answers there would be correct. Both answers would be correct. All right, number 3. So in this case, we're finding all of the solutions. So if we were to take x is equal to arc tan of root 3 over 3 plus n pi. What's this one going to give us? Carlos? Pi over? Pi over 6 plus n pi. A little bit of bit slow there answering. So let's have a quick reminder of the exact value table. Let's have a reminder of our exact value table values for tangent. Just a quick reminder here, we're going to have 0, we're going to have 1 over root 3, 1, root 3, undefined. Yeah. And if you notice, I'm moving between the 1 over root 3, which is my preferred form. It looks simpler to the rationalized form, root 3 over 3, just to show off. There was no reason in that. I'm just flexing.
For the first question, could it be plus minus 5 pi over 4?
Yeah, it could be. We wouldn't normally write that one, but yeah, that's going to work as well. Because obviously this one's 5 pi over 4, and this one is minus 5 pi over 4. I would read the wording carefully. Generally, they're looking for simplest possible form, and it might be considered not to be the simplest possible form to have minus 5 pi over 4.
So always principal value?
For the cosine one, sometimes for the sine one, I like to rotate it like we did here, instead of having minus pi over 2 to 3 pi over 2. But other than that, yeah. So with tangent and sine, if it's in the fourth quadrant and it's negative, I tend to rotate it all the way around. But with the cosine one, it should be in the first or second quadrant. All right. So solving trigonometric equations. Let's have a particular angle. So what we need to do first is to isolate the trigonometric function on one side, find the corresponding angle, and consider the restrictions to write a general solution. So for this example here, what can we do? We want to get it to the point where it is sine theta equals A. You're aiming for this, where A is some kind of a constant. So for this equation, how could we do that? Well, we could divide through by 6. That's going to give us root 2 over 2. What would the answer be here for this one? Theta is equal to pi over 4 plus n 2 pi. Anything else?
Negative pi over 4.
No, that's for cosine. Let's look on the... So do a unit circle to sketch. Do a sketch of the unit circle to help you catch little errors. You don't have plus minus for this one, that's for cosine. So the angle that the value that we're looking for is this one, 0.707. This is y is equal to root 2 over 2. Now, with sine, it's the y value. So our first angle is this one at pi over 4. Our second angle isn't going to be minus pi over 4. It's going to be over here. And this one is always given as pi minus pi over 4. No matter how odd your angle is that you're getting, the pi minus that angle will work, and it'll give you an angle of x plus n 2 pi. Simplifying that, what would we get as our second set of solutions? So we've got pi over 4 plus n 2 pi and 3 pi over 4 plus n 2 pi.
You couldn't just do plus or minus pi.
No, that would be for cosine only. Sine is always the longest answer to write. Jude. Tangent is easy because it's just because of the period. It makes it the simplest to write. All right, have a go at this one for yourselves. Okay, so what's going on graphically? We are going to have a cosine function looking like this. And we are looking for the point where it goes through here like this, at the line y equals 2. But all we need to do is we want f of x to equal g of x. So that means we want 3 plus 2 cosine x to equal 2. So 2 cosine x equals minus 1. Cosine x equals minus a half. Let's use our sorry. What is the arc sine of minus a half? So, not quite. So if we think about our unit circle here, we are going to want the cosine of x to be minus a half. That means we need an angle over here. So this is x is equal to minus a half. What the exact value table gives us is this one here, which is at a half, and this one is pi over 3. So the one that we want here is 2 pi over 3. So this is going to give us 2 pi over 3, and then we need plus minus and plus n 2 pi. So the arc cosine function will give us 2 pi over 3. The rest has to come from the logic. Okay, so we've seen earlier in the course a little bit that if we want to take a trigonometric function and raise it to a power, we write it like this one to avoid ambiguity. So we have a trigonometric equation here to solve. The function g is given by g of x is equal to 3 minus 4 sine squared x. What are the zeros of g in the interval 0 to 2 pi? Let me do this one for you. So if we want the zeros, we take the function, it's g. We take the function g of x and set it equal to 0. This gives us this as our equation. So we want to rearrange it a little bit now. We'll get sine squared x is equal to 3 over 4. Now, square rooting both sides is going to give us plus and minus root 3 over 2. This is going to lead us into a whole bunch of different solutions. So, for a quick sketch of the unit circle. Is the sine function the y value or the x value? So we want the y value to be root 3 over 2, and we want the y value to be minus root 3 over 2. So this is the line y is equal to root 3 over 2. This is the line y is equal to minus root 3 over 2. From the exact value table, we get this angle here. What's this angle going to be? This one is going to be what? Pi over 3. This is pi over 3. What's this angle going to be? So this one is given by pi minus pi over 3. So our solutions are going to be x is equal to, it's going to be tons. We've got pi over 3 plus n 2 pi. We've got pi minus pi over 3 plus n 2 pi. We've then got this one down here. What one could this one be? Negative pi over 3 is an easy one to come for that one. Or 5 pi over 3. I'm going to go for the negative pi over 3 to begin with, plus n 2 pi. And this one over here. What's this one going to be? 4 pi over 3. Oh, I'm missing my pi. 4 pi over 3 plus n 2 pi. So just tidying that lot up, this gives us x is equal to pi over 3, 2 pi over 3, 4 pi over 3, let's put them in order, and 5 pi over 3.
Can't have negatives because of the domain that's set for the answers.
Oh, sorry, we don't need the n 2 pi. That's right. Let me write this as a set. So we want for our answers pi over 3, 2 pi over 3,
4 pi over 3,
4 pi over 3, 5 pi over 3.
You can't have the negative because the restriction was set from 0 to 2 pi. Make sure you put that slide up.
Yeah, I've got it all set to go. All right, have a go at this one. Let's run through this one. Okay, so what are all the values of theta and 0 to 2 pi, where cos squared theta equals minus? All right, so what we want to do for this one is we've got the cosine squared of theta is equal to minus cosine of theta. I would never divide through by a variable. If you're dividing through by a variable, if you're cancelling cosine theta on each side, you are losing solutions. You are losing the solutions cosine theta equals 0. It is always neater and better to factor. So we get cos squared theta plus cosine theta is equal to 0. Then we factor out the cosine theta. This is the one you would divide through by. And we get cosine theta plus 1 equals 0. Now, this gives us two possible equations. We've got cosine theta equals 0, and we've got cosine theta plus 1 equals 0. This is cosine theta equals negative 1. These ones we can solve pretty quickly and easily on the unit circle. So if I just pull up a unit circle for us here, is it the y values or the x values for cosine? It's the x coordinates on the unit circle. So we want the x coordinate to be 0. So the first equation is going to have solutions here and here, and the second solution is going to have solutions here. We only want solutions in the interval 0 to 2 pi. So that is going to give us theta is equal to, and our first solution would be pi over 2, our second would be pi, and our third would be 3 pi over 2. Are there any other solutions? No. Have a go at this one. What time is it? Okay, now let me run through the last two for you a little bit quicker. Make sure we finish on time. Okay, so we've got the function 2x sine x squared x, and g of x is root 3 in the xy coordinate. Find the intersections of the two graphs. So again, we want f of x is equal to g of x, which is going to give 2 sine squared x is equal to root 3 sine x. So moving it across, we get 2 sine squared x minus root 3 sine x equals 0. And then factoring. What should we factor out? We can only really factor out the sine x on this one. So this gives us sine x is equal to 2 sine x minus root 3. Our two solutions are going to be sine x equals 0 and sine x equals root 3 over 2. So now, we draw a little unit circle to help us. Is sine the x values or the y values? It's the y values. So we want a y value where the y value is equal to 0. It's going to be here and here. And we also want where the y value is equal to root 3 over 2. So that's going to be this line here. This is the line y is equal to root 3 over 2. So this one is going to give us, we're only in the interval from 0 to 2 pi on this one. We're only in the interval, notice here as well, that 2 pi is not included. If there was an equal sign here, then 2 pi would also be one of our solutions. Because we have a solution at 0, we could have a second one there at 2 pi, but our interval is restricted to just less than 2 pi. So our first solution is going to be x is equal to 0. Our second solution comes here. What is the angle that we use here for this one? This one's pi over 3. Our third solution is going to be this one over here. What would that one be? 2 pi over 3. Our fourth solution would be at pi. We might have a fifth solution if it weren't for the fact that this is a excluded inequality there at the top end. So we only get 4 solutions for this one.
When you try to trick us with that, like sometimes just put the equal and
Yeah. Oh yeah, very, very much so. Check very carefully what your inequalities are here, and then just pause at the end and say, wait a minute, am I getting one there as well? Yes, you will, John.
if it doesn't include 0, it only includes 2 pi, you do the lower half of the unit circle.
What you mean?
If the inequality doesn't, if it only includes 2 pi, you do the lower half of the unit circle.
No, this interval would give us almost the same solutions. We're going to get pi over 3, 2 pi over 3, pi, but then we would have 2 pi as our final solution. So that interval would produce a different set of solutions to this equation. All right, exam style question. 2 minutes for this one, please. Okay, this one is a non-calculator question. This one is a non-calculator question. So what we need to do, can we have quiet? we need to solve this one. We need to, so we have this particular model. Which of the following statements is true? When is it increasing and when is it decreasing? So I think what we want to do for this one is, what is the maximum value this function produces?
324.
How do you get that?
Because for the sine function, the maximum value is 1. So we can just use the 174 plus 150.
Excellent. So with a trigonometric function like this one, it looks really complicated, but the maximum and minimum values are quite easy to find. The maximum value is going to be given by 174 plus 150, which is 324. The minimum value would be 174 minus 150, which is going to be 24. And the way we're doing this is you can ignore all of this bit. You can ignore all of this bit because the only thing that's going to create the maximum and minimum values is this one. This part of the function has its maximum as as 1, and its minimum as minus 1. So this is going to output plus and minus 1. So you can use that for your solution. What we need is we need to find out where the maximum and minimum are. So if we take the equation sine of 2 pi over 365t is equal to 1. We wish to solve this one. So if we're interested in solving it, we're going to get 2 pi over 365t. What is the arc sine of minus 1?
0.
Isn't it going to be pi over 2? So this is going to give pi over 2. We can cancel the pi's. We can divide it through, and we're going to get t is equal to 365 over 4. We need to simplify this. So for me, what I'm thinking in my head for this one is that I know that 3 times 90 equals 360. We use 90 degrees, and we use this quite a bit. So sorry, not 3 times. 3 times 90. Sorry, 4 times 90. I'm using this. That helps me. So 5 divided by 4 is going to be what? That's going to be 1.25. So I've got 91.25. That's my first solution. So I can see it's going to be around one of the two. I've limited it down to 2, but I also need to consider when my minimum is going to be. So I'm going to need to do the same type of thing here for this one and find my minimum value at minus 1. So my minimum value is going to be when we have 3 pi over 2. So I get 2 pi over 365t is equal to 3 pi over 2. Moving around and cancelling this time is going to give us 3 times 365 over 4. So basically it's 3 times that previous answer. And that's going to give us something, that means we've got t is equal to 3 times 91.25. That's going to give us something around about the 274, isn't it? All right, so we now need a sketch. We need a sketch to help us. Sorry, can we have quiet, please? I want to get this all finished. This is the sine function, and it has been vertically transformed and dilated, so it's looking something like this. We want the interval where we go from here to here. So we know this one's at 91 and this one's at 274. So that one's at 91, 92. This one's around 274. So from 0, it's not going to be decreasing from 0 to 182. It's, in fact, that's this, probably this bit here. So that's A. It's not that one. B, it's decreasing from 92 to 273. Yeah, that one's true. This next one, C, is obviously going to be this interval here. No, sorry, C is this interval here. And then D is where it's there and there. So D would be increasing. This would be increasing on those two intervals there. So it has to be B. All right. That's it for the lesson today. I'd like you to go to, hold on a second.